of all, let me convey my hearty wishes for attending for this faculty development program as a resource person, ma'am. Really, we are grateful to you for giving your valuable time. So, before diving into the session, let me brief introduction about Dr. Rithika Mehera. Dr. Rithika Mehera is working as professor and dean of School of Computer Science and Engineering at Devbhoomi Uttarakhand University. She received her PhD degree in computer science from Gurukul Kangri University, Haridwar in the year of 2010. She received MTech degree in computer science and engineering from Uttarakhand Technical University, Dehradun. She specializes in core areas of computer science and holds experience of more than 18 years. She is an innovative person with deep knowledge of computer networking, mobile computing, data mining, big data analytics, etc. She has also published many research papers in various national and international journals of reputed publishers such as IEEE, Springer Nature, Elsevier, and CRC Press. She has organized several workshops, seminars, STCs, FDPs, and conferences. She has delivered several invited talks. She is associate editor and guest editor to many international journals. She is lifetime membership of the Indian Science Congress Association, Computer Society of India, Institute of Electrical and Electronic Engineers, and the Institution of Electronics and Telecommunication Engineers, ACM and IEEE. She was chairman of Computer Science of India, Dehradun chapter. She was vice chairman of Computer Society of India, Dehradun chapter in the year of 2012 and executive body member in the years of 2008, 9, 10, 11 of Computer Society of India, Dehradun chapter. She is associate grade member of IEEE since May 2010. She is SPOC of NPTEL local chapter, DIT University, Dehradun. She received certificate of appreciation for instrumental role as a SPOC NPTEL DIT chapter 2016 and 17. She has also received memento for SPOC active chapter at IIT Kanpur. She received active participation woman CSI Dehradun chapter award at CSI annual convention 2015 New Delhi. She received Education Excellence Award in National Summit on Women and Education Excellence on 17th January 2020 at New Delhi. And she received Global Education and Corporate Leadership Awards as Best Young HOD Award in 2nd International Award Summit on 15th December 2019. She has supervised a number of research scholars and many others are presently under her guidance. She is involved in various other activities to give students full exposure to recent developments and various advanced industrial trends. Really, we are lucky to have you in this FDP, ma'am. Ma'am, now I request you to enlighten us with sharing knowledge on deep learning technique for diagnosis of heart disease from ECG signals, ma'am. Now the platform is yours, ma'am.
Thank you so much, sir. Thank you so much. I'm highly obliged that Sri Vishnu College has called me again for this FDP, and Kiran Prussi sir is always being in touch with me. So I know how much he is going to do for their institute and the university. So I am going to share my slide now. Sir, it is visible there?
Yes, ma'am.
Yes, ma'am.
So thank you to giving me opportunity so that I can share some of my views regarding the deep learning techniques for diagnosis of heart disease from the ECG signal. Basically, before starting this topic, I'm just going to give you the brief overview of artificial intelligence, machine learning, and then deep learning, how these are interrelated to each other, and then the applications why we are going to adopt the deep learning techniques now. Then going to the one of my paper, SCI paper, that has been published in the February 2021. Which is having a similar topic to diagnose the heart disease from ECG signal. So basically, the automated heart disease signal from the human heartbeats is a challenging and intellectual assignment in the signal processing, because periodical monitoring of the heartbeat arrhythmia of the patient is an essential task to reduce the health death rate, so that we can avoid it, and it can be cured on time. And basically in this paper or in this slide, which we are going to discuss later on, the paper, research paper, it is focuses on the hybrid convolutional neural network architecture, by making use of Grasshopper optimization algorithm to classify the different type of heart diseases from the ECG signals. So as an artificial intelligence approach is a widely used in the computer vision based medical analysis data, and the traditional CNN cannot be used here for the heart diseases to analyze the ECG signal, because it creates a lot of noise or irrelevant data is mixed with it. So here we have used the CNN architecture to diagnose the medical data through the ECG signals by means of ECG signals. So this study basically utilizes the pre-processing and selection of the feature for proper heart diseases classification, where we have used the discrete wavelet transformation for the noise algorithm is used for the selection of the and from this the better accuracy we have received for the classification. And for training and testing, the project heartbeat classification model has been prepared, and we'll discuss about the which data set I have used, and so that my model has given almost 99.58% accuracy, and there was a very less 0.42% error rate. So how the assortment of R peaks and RR intervals has been done. So all these things we are going to discuss. So moving to first slide, my first slide. So what is artificial learning? So everybody knows artificial learning is artificial intelligence is based upon the learning, perception, reasoning. Perception is the environment that has been scanned by the various sensor organs, we can say. The reasoning, what type of inferences appropriate situations we are going to draw. It is related to the problem solving, knowledge, and planning. So we can say it is an ability of a digital computer or computer controlled robot to perform tasks commonly with the intelligent beings by using all these functions: learning, perception, reasoning, problem solving, knowledge, planning. So all these things are required, and decision making always. So I'm going to show you a small video which gives you an idea how the AI is going to play nowadays in our life, and how the small robots are going to work in the collective environment. See here the small video.
में था वहां से फिर उसने आपका ट्रांसफर लीडर क्या किया उसने खर्चे आ गए पुनः अगर है उसका डिजाइन की प्लान कर रहे थे हमारे बढ़िया तब मुझे पता चला कि ये भी अच्छा है
Sir, are you able to see the video?
Yes, ma'am. But we are not getting voice, ma'am.
So, one.
It's not audible, ma'am.
Sir, voice is not able to,
Yeah.
I think, yeah. I have shared all the thing, voice is there. So generally in this video, sir. Now, sir, you are able to listen that?
No, ma'am. Video is visible, but we are not getting audio.
Madam, while sharing, you also share that audio also sharing. Audio sharing option will be there, madam. Audio sharing option.
Sir, 1 minute. I'm again presenting it. Audio sharing option. Sir, again, it is audible now?
No, ma'am.
So I'm moving forward. Just in this slide, what has been observed, the micro robots are working in the collective environment, and one programming has been shared with another robot, and actually it is based on the colony optimization techniques. This has been shown in this video. So I'm moving to the next slide, just showing what is artificial intelligence. What is machine learning and the deep learning. As we know, artificial intelligence is the broader concept, a program that can sense, reason, act, and adapt. The subset is the machine learning. Here we are talking about more on the algorithms whose performance improves, they are exposed to more data over the time. And the deep learning is the subset of machine learning in which the multi-layered neural network learn from the vast amount of data. So machine learning, these programs learn from the repeatedly seeing the data rather than being explicitly programmed by the humans. So emails are labeled, here we can see in this figure, the emails are labeled as spam. Machine learning program, spam or not spam, machine learning program see this, all these things, and categorize it into the spam and not spam type of emails, the better it gets the classification idea from the machine learning. Now in the deep learning concept, because in the machine learning, we are doing the feature detection and machine learning classifier algorithm has been used. These two steps have been merged in the form of the hidden layers in the machine learning. So the step 1 and step 2 are combined into a single step here. So if we talk about the machine learning, when it came into the existence, so late in 1990s to early 2000, there is the advancement in the SVM algorithm becoming a machine learning method of the choice. AI solutions have successes in the speech recognition at that time, and then medical diagnosis and robotics and many other areas came into the existence. AI algorithms were integrated into the large systems and became useful throughout the industry. The Deep Blue chess system beat the World Chess Championship Garry Kasparov at that time, and Google search engine has been launched using the artificial intelligence technology. So this was till 2000, and after that the concept of deep learning has been raised. In 2006, Geoffrey Hinton publishes a paper on the unsupervised pre-training sets, where the deeper neural networks is to be trained, and neural networks are rebranded to deep learning name. So in 2009, the ImageNet database of human tagged images is presented in the conference, the CVPR conference, and algorithms compete on several visual tasks at the first ImageNet competition. So deep learning breakthroughs in 2012, the deep learning beats previous benchmark on the ImageNet competition. In 2013, the deep learning is used to understand the conceptual meaning of the words. In 2014, the similar breakthroughs appear in the language translation, and these have led to the advancement of the web search and document search and document summation and the machine translation. In 2014, the computer vision algorithm can photos. Deep learning platform TensorFlow is developed at this time. In 2016, DeepMind AlphaGo developed by the Aja Huang beats Go masters Li Su Don. So we can see the deep learning impact where the computer vision came into the existence, and we are going to use the natural language translators at this time. So we are having a self-driven cars for the which are going to detect the object, and now have been used in the healthcare improved diagnosis also. So AI now has been the deep learning subset of the AI is used in the healthcare, medical diagnosis, in the agriculture, in optimization of network, in telecommunication, in automobile, in natural language, in education, in business, in banking, in risk remedies. Everywhere we are going to find out. So this era we are talking about the bigger data sets, faster computers, neural nets. So cutting edge results are found. So other modern AI factors is there is a continuous expansion of open source artificial intelligence, especially in Python, which aids the machine learning and big data ecosystem. It leads to the deep learning libraries. Open source allow further adoption by the energy. Open sourcing of the large data sets of millions of labeled images, text data set, out of which we have also used in my paper for the classification of heart diseases using the ECG signals. So we can see a lot of application in the various areas of the world. In the finance sector, surveillance sector, social media, entertainment, robotics, agriculture, e-commerce, education. So AI in automobile. We can see the self-driving cars, during which the autopilot by Tesla has been a front runner, takes up the data. Am I audible? Sir, I am audible or not?
Yes, ma'am, you are audible.
Okay. So the goal of the self-driving cars during the autopilot by Tesla has been the front runner, takes up the data from all Tesla running on the roads and use it with the machine learning algorithms. The assessment of both chips is later matched by the system and followed if the input from both the sides is same. So in this way, the AI plays role in the automobile. So here we can see few figures where we can see the driver assistance, autonomous vehicle, connected vehicle, manufacturing, quality control, supply chain. So every arena of the world, or every arena of the automobile, or every arena of the different engineering aspects, we are using the artificial intelligence, machine learning, and deep learning. So latest AI projects across the industry we are going into day-to-day lives are the self-driving car, voice assistant, robotics, healthcare, customer electronics, all these things. So if we talk about the medical diagnosis, so artificial intelligence has become a synonym with the support and efficiency in the medical community. From technology viewed with the suspicions as claims touted, it is replacing for the medical professionals, and AI has evolved to become a second pair of eye nowadays, we can say, that never need to sleep. So medical diagnosis everywhere or in healthcare provides the overloaded medical practitioners with the facility, with reliable support, which helps in minimizing the workload pressure. So we can see the artificial intelligence in the medical helps in the medical decision making system, the management, the automation, the admins, the workflows, all these things. So here we can see AI used in the education as well, not only in the online thing. Now again, we are making use of the student monitoring system in with the help of AI. The psychological, mental, physical well-being of student means you can say all-round development of students.
We are not able to see your slides, ma'am.
Sir, I am going to share you again.
Okay. Yes. Yes,
sir,
ma'am.
is it visible now?
Yes, yes, ma'am. Please proceed.
So use of AI in gaming. AI is employed to give the responsive, adaptive, and intelligent behavior in the non-player characters as well, which has a human-like intelligence in the video games. And as we know nowadays, the games that the PUBG mobile system and Garena Fire, the childrens are playing. So the intelligent behavior where the non-player characteristics are lot of non-player characteristics characters are playing with the person. Even the real-time game playing are going to be done with the help of AI. So it serves to enhance the chance of the game player to experiences like another human is playing on the another side. So here we can see few of the gaming type of things that have been used by nowadays by the kids, where we are going to play with the help of the Google lenses, with the 3D reality, tic-tac-toe game, and many other. So AI in social media, we are going to talk like everywhere in Facebook, Gmail, YouTube, everywhere, Twitter. So there is a use of AI. So omnipresence has been seen in the transportation where Google and Waze find the fastest route by processing data traffic. Uber, Lyft predict the real-time things using AI techniques and deep learning techniques. Omnipresence can be shown to decide what content has to be presented to the person depending upon the recommendations. It presents the different content, image recognition, sentiment mental analysis has been ensured that content appropriate moods, natural language and object detection. We carry out powerful natural language processing algorithms in our phones and computers. So Amazon Deep Lenses and Google Clips are used for the object detection. So latest development is the computer vision, which I have used in my paper also, where deep learning has proven to work with the image classification, and the object detection model beats the previous benchmarks. So this is the working model of AI in healthcare, where the security experts train the data and decide if unknown attacks occur. It selects the appropriate approach to mitigate the damage. Now I come to my paper, the intellectual heartbeat classification model for diagnosis for heart disease from the ECG signal. Here, automatic heart disease detection for human heartbeats is challenging an intellectual assignment in the signal processing, as I have told you. So here we have designed a convolutional neural network architecture, which make use optimization technique, Grasshopper optimization technique, to classify the heart disease. And discrete wavelet transformation has been used for the noise reduction. Small algorithms, I will also show which type of algorithms we have written. So Grasshopper optimization algorithm is used for selecting the peaks. Here in the ECG signals, we have taken the feature sets like R peaks and RR interval for the classification accuracy. And the data set that we have taken is the MIT BIH Arithmetia database. This database been utilized, and the 16 heartbeat disease has been categorized. We have proposed the heartbeat classification model, and it was verified by the earlier work that has been done by the Kailash, and it has been found that our classification technique is better than his technique. So what we have done, the average classification accuracy of our algorithm is 99.58, and the robust responses we have received, and misclassification beats were only 108. It means the 0.42% error has been observed. So just giving you overview. Here you can see the ECG signal segment. R peak is denoted by the red dot. R n minus k depicts the previous R peak time position by the way of respect of Rn reference beat. Rn plus k is the next R peak time position by the way of respect to Rn reference beat. So Rn minus k, Rn plus k is the R peak difference, you can say, between the two time locations. So this is the way we are talking about the interval. So this is the model which we have proposed, and this model we have used to classify the images. So ECG signal that has been taken from signal images have been taken from MIT BIS database. It has been pre-processed, and then RP detection and segmentation has been done. While doing this, the smoothing process, discrete wavelength transformation we have used for the segmentation of the data, through which we have found the RR intervals and R peaks. And then all this data has been inputted to the CNN, and using the optimization algorithm, a confused matrix have been prepared for the for analysis purpose, and we have trained the data set, and then the trained data sets has been tested, and it has been found that the model that we have proposed give more accuracy than the previous model. So here we can say the steps that we have followed in the HCM. Initially, we have uploaded the ECG signal, the proposed intelligent heartbeat classification model First step is to upload the ECG signal. So numerous signal pre-processing techniques are used, and out of all that, the opposite segmentation method is used, which put into the isolate out the peaks from the ECG signal. And to improve the signal quality, DWT based smoothing is done. It is used to minimize the unwanted noise that is with the ECG signals. After that, the features will be extracted like R peaks and RR intervals from the segmentation of the ECG signal, and this has been applied to the feature selection using the Grasshopper optimization algorithm. We feed such input to the CNN and typically train and test the HCM model, heartbeat classification model. So here we can see this is our database. The 16 different type of classes we are able to see over here, and training, how much training data was there for each classes, and then testing has been done, has been mentioned in the table. So we can see left bundle branch block and right bundle branch block. So these type of classification classes we have created. So broad outlines, if you want to understand, so we introduce a new ECG signal segmentation method centered on the combination of the smoothing technique along with DWT. For classification of ECG heartbeat into 16 heartbeat disease categories, the CNN classifier is used with a Grasshopper optimization feature selection algorithm with novel fitness function. For authentication, we estimate the performance parameters like accuracy, error rate, sensitivity, specialty with the classification time associated with the state-of-art methods. So here we can see this, the first one. This is the original uploaded ECG signal, and then after that, the pre-processing which we have done, this type of thing we have received. Smoothing process, that after applying the smoothing process. So what we have done in the smoothing process, this was our algorithm. So original ECG signal and estimated noise has been shown by N. So output, we are receiving the smooth ECG signal. We are denoting it by SM. So first determining the size of the ECG signal, SZ, and then according to this size we have put the for loop, and we segment the ECG, split the signal into the structure of N, and then how we calculate the signal variation, we check the neighboring peaks position and their variation in the ECG signal, and then we accordingly we have estimated the noise level, and the maximum variation have done checked, and then we have estimated accordingly how much noise is there, and then we have applied the smoothing. So difference we have find out between S comma estimated noise level, and accordingly we have smooth the signal. So final signal that we have received is the SM. This was the smoothing process. And discrete wavelet transformation decomposition signal. Decomposition signal into LPS and HPS, high pass signal and low pass signal. So the coefficients, these two coefficients are used to smooth the ECG signal. So what we have done in it, so when DWT give the output, it give the coefficients which is used for the feature analysis. So we smooth the ECG signal which is received in the form of SM, and the level of wavelet is N. The family of wavelet we have taken as HAR. So we decompose the coefficient. One is C, one is L. So one is for the low pass signal, another one is for the high pass signal. So within the range of SM, So we have initialized these two things, and then we have performed the discrete wavelet transformation to remove the noise and smooth it further. So decomposition factors are going to be stored in the two variables C and L. After this, the filtering of ECG signal has been done. So we have calculated with the help of the threshold noise in it. So ECG signal coefficient using DWT, which we are having two coefficients. C of noise in the signal is shown by T and level N, and the family of wavelet again by HAR. So what we have done, we initially determine the size of C and L and store it in CLL. So applying the for loop and repeatedly we have to perform this filtering process in the ECG signal. And final, the threshold point, when we have passed the T, that is the threshold point of the noise in the signal, and after that the signal have been created, which is filtered one, and then this has to be inputted to the Grasshopper optimization. Feature analysis of ECG signals is to find out the R peaks that has been done over here. So x-axis determine the recording time in millisecond, and y-axis determine the amplitude of ECG and QSR peaks. So in this figure, we are able to see the R peaks and RR intervals. How we have find the R peaks and RR intervals. You can see here. So this time is shown, RR interval time is shown 314 millisecond, 315 millisecond, 321 millisecond. In this type, we are getting the final result. So feature selection using Grasshopper optimization algorithm, it is inspired by the Sur Intelligence, where the group particle observation is there, and similar type of video I have shown you in the previous slides. I think the voice is not audible at that time, but the main motto behind to show that video is to show how the multiple robots are working collectively, and how the grouping of the swarms gives you the proper output. So different behaviors are observed in nature, hence different algorithms are there. So taking the inspiration of these nature-inspired algorithms, so we have adopted the Grasshopper optimization algorithm for the feature selection in our work. So classification is done using the convolutional neural network. It has been initialized in two phases, training and testing phase. So architecture has been shown over here. The architecture that we have taken of convolution neural network is shown, where we use the pooling, and the fully connected data will give you the final result. So CNN is used to train HCM. HCM is our model, the proposed model that we have proposed, that is heartbeat convolution neural network model that we have proposed. The map extracted feature from the input image has been used. The convolution map has been used in the form of the extracted feature from the input image. Maximum pooling map is the alternate feature selection, which act as a optimization technique that we have used as a Grasshopper optimization technique. So ReLU function helps in fast training. Is the activation function of CNN. And the performance analysis of proposed heartbeat classification for each disease group of event is estimated by figuring the quality centered evaluation parameters. True positive is for original feature of testing. True negative and false is the false feature with respect to the training of the CNN. False positive is the false feature during the testing. False negative is the true feature for training of CNN parameters. So in this way, we have actually categorized our things. Based upon these quality parameters, the performance matrix for each ECG signal is calculated. So the confused matrix of the proposed heartbeat classification model has been produced. The corrected classification heartbeats is, you are able to see 86005. Here it has been shown, the figure. Accuracy, we have achieved 99.58%. So misclassification beats are 108. So you can see the error rate is 0.42%. So predicted heartbeats have been shown over here and actual heartbeats also. So what we have done, it signifies the contrast of the proposed work with the previous work, and the sensitivity is calculated by the formula as shown over here. True positive upon true positive plus false negative. So we have plotted and compared with the previous work that has been done, and we have find out that our models work perfectly good than the previous model. So performance parameters also taken, like sensitivity is one of the parameter that we have taken. Other parameters we have taken, and here you can see all these parameters. So existing report, earlier report, and the proposed that we have taken out has been shown over here. So you can see the result is better. The time, you can notice the time our model is taking quite less. Error, you can see here. The existing model is going to give this much of error, and our proposed model is going this time. Accuracy, you can see. So all these performance parameters we have worked on. We have worked on the MATLAB, and then the results. So the proposed heartbeat classification model yields an enhanced classification accuracy of 99.58% on the standard MIT BIH arithmetic database. It is a PhysioNet repository. You can also use the data for the classification purpose. For the case of extended inception, the optimized convolution neural network that is used in our research is misclassification error of system is reduced up to 64%. So we can imagine it is 63.34% faster. So in future, what we are going to do, the same model we are using with the back propagation step that we have not included in it, and we have trained the disease classification system in it using the electrocardiography heartbeat signal, which help to reduce the detection time of the system and can be used in the real-time scenarios. So still the work is on and we are working on it. So 2 papers out of this we have carried out in our research and are published in the Springer in the SN Applied Sciences. So here you can see, and the DOI and the Springer Nature Journal, the new Springer Nature Journal which has been accepted for this paper. So this is all from my side. Thank you. If you have any questions, you are welcome, please.
Thank you so much, ma'am. Participants, if you have any queries, please unmute yourself and you can ask.
So any me regarding this, if you have any queries related to the deep learning concept and the convolutional neural network, still working on, and certainly we are going to help on your queries. Please, you can ask any queries from the thing that I have described. So may I know who is the audience? It is from the Vishnu Engineering College. Any other colleges, faculties have also joined?
Yes, ma'am. All the faculty from different colleges.
Acha. So, sir, I think nobody is going to ask the question out of it.
I hope
I thank you.
they are very much clear about the topics, ma'am. I hope
Yeah,
that's-
I thank you. Sorry, sir. I thank you, Krishna Prisa, for giving me the opportunity to and the platform to speak on this topic. I think this is going to help you, and if you are going to do the research work in it, many things are there. Not only this, like many things on the deep learning concepts, people are working, and we all always welcome if you are having interest in collaboration with us also. So we are going to submit few of the projects related to this. So if anybody is interested, can mail me or talk to me on this number. So it has been mentioned on the screen. I think my slide is still visible, sir.
Yes, ma'am. It is visible.
Thank you so much, sir. Thank you so much.
Yeah. Thank you so much, ma'am. Despite of your busy schedule, you spend
Yes,
your
sir.
valuable time with us to share your knowledge. And thank you so much for your open hands for collaborate with you to work on deep learning and especially you already worked with Grasshopper optimization algorithm, ma'am. So really, it is a wonderful
Yes.
algorithm. So thank you so much, ma'am, for attending this faculty development program as a resource person. Thank you so much.
Thank you, sir. Thank you, sir. Should I leave, sir, now?
Yes, ma'am.
Okay. Thank you,
Sir,
sir.
Thank you, madam.
Thank you, sir.
Sunil garu, thank you, and